Activity 2.1 Debugging Tools. Obtain the folder Activity 2.1 Error. This folder contains the VLS for this part of the activity. Inside this folder, open Activity 2.1 main.vi by double-clicking on the file. The FP appears. Notice that this VI is non-executable because the run button is broken. Number 2. Press Ctrl E to make the VD of the VI appear. Notice that there is a sub-VI called Activity 2.1 sub.vi. Double-click the sub-VI and the FP of this sub-VI appears. Number 3. Press the Broken Run button in the Activity 2.1 main.vi, FP or BD. The error list windows appear. Number 4. Perform the necessary steps to correct the errors and make the VI executable. Number 5. When the VI is executable, click the Highlight Execution button in the toolbar of BD to start animating the flow of data in the VI. The Start Single Stepping button causes the execution of the VI step by step. Continue pressing this icon until the data enters the sub-VI, in which the same button in that sub-VI's windows can be pressed. The execution is finished.
Kumbaga dito sa start single stepping, dito makikita yung flow ng yung pagkasunod-sunod ng execution. Dito mauna yung sa addition muna, after ng addition pupunta siya sa division, then after that tapos na. Yung finish naman, pag tapos na yung lahat ng execution, pipindutin mo to para ma-stop yung
Note: when the data enters a node, it is automatically reflected in the FP. To make the VI run at its normal speed, click on Do Not Highlight Execution. But after using this tool, click on View, Tools Palette, and the Tools Palette window appears. There are various tools in debugging and interpreting the BD can be seen. Click on the probe data icon. To place probes on wires, the probe watch window appears. When the VI is run, data that passes through the probe is displayed in the window.
So, pag naglagay tayo ng probe, may lalabas na window dito. Yan, may dalawa. dito makikita natin kung ano ba yung nilalaman nung node, yung mga lines dito. Halimbawa, i-play natin. Mag-i-input tayo dito ng ng value. 4 and 5. Pag pinlay natin siya, makikita natin magbabago yung value dito sa probe watch window. Pag pinag-add natin yung 4 plus 5 is equal to, ang sum niya is 9. So, etong 1, nakalagay siya 9. Pag dito naman sa average, ang lalabas is 4.5 kasi ang average ng 4 and 5 is 4.5.
You can add text in the VD by using the Edit Text tool to add comments and describe the functionalities of certain parts of the VD. The Breakpoint tool
Dito sa add text, pwede tayong maglagay ng comment dito. Halimbawa dito sa ilalagay natin, this is the sum of the two inputs. Yan. So, ito parang comment lang siya. Halimbawa dito rin naman, this is the average of the two inputs. Yan. Kumbaga dito, parang wala siyang gagalawin sa program. Kumbaga comment lang yung i-output niya.
can be placed on wires to post the execution of VI. When it enters the breakpoint, click the Continue button to resume the operation of VI. Click the breakpoint icon again to remove the place breakpoints and to stop placing breakpoints.
Yung dito naman sa breakpoint, ito yung breakpoint tool. So ginagamit siya para ma-post yung halimbawa nag-execute ka ng program. Kumbaga ipo-post niya muna kung saan mo ilalagay yung breakpoint. Halimbawa dito natin ilagay. So pag pinlay natin, yan, magpo-post muna siya. Pag kinilik natin yung continue, dediretso siya diyan. So, ayun yung activity 2.1. Next.
On activity 2.2, building a system
Okay.
Building a system VI with Express VIs. Create the VI. Activity 2.2.vi. Build the following VD and FP. In the VD, insert Simulate Signal Express VI, Functions Palette, Express Signal Analysis, Simulate Signal. The Configure Simulate Signal will appears. In this window, set the frequency to 200, amplitude to 100, sample per second, hertz to 8,000. Uncheck the automatic checkbox under the number of samples category and set it to 128. This generates a signal whose amplitude is between 100 to negative 100, frequency of 200 Hz. The timing information enables one to see clearly the signal by setting the sampling rate, samples per second, and the number of samples correctly. Click OK. Place a scaling and mapping Express VI. Function palette, Express, arithmetic and comparison, scale and map. The Configure Scaling and Mapping windows appears. In this configuration window, choose linear and set the slope n to 5. This will scale the amplitude or amplify the input 5 times. Click OK. Wire the sine output of the simulate signal Express VI to the signal input of the scaling and mapping Express VI. Note: the wire used for connecting the Express VI together is for a dynamic data type. This is, it carries dynamic data or data that change over time. Switch to FP. Insert a waveform graph. Control palette. Express graph indicator. Waveform graph. Right-click on the waveform graph. Choose X scale and uncheck the lose fit option and ignore time stop. Right-click on the waveform graph, then choose Properties. On the Display Format tab, under the default editing mode, set the time x-axis data type to floating point. Then choose digits of precision as the precision type. Set the digits to 2. Switch back to BD. The terminal icon for the waveform graph should have appeared. Connect the outputs of the scaling and mapping and simulate signal Express VLS to the waveform graph. On the process, the merge signals node appears automatically, and close the diagram with a while loop structure to make the program run continuously.
So after neto, irarun na natin, titingnan natin kung ano yung lalabas
Ba't
sa.
niyang umandi?
So pag pinlay natin, makikita natin yung waveform niya. Yan. Tapos pag in-stop, mag-i-stop.
Activity 2.2. Building a system VI with Express VIs. Number 1. Create the VI activity 2.2.vi. Build the following BDNF.